So we have completed get functionality as well on a singly linked list, right? Now let's try to perform a set functionality on a singly linked list. So what exactly a set functionality does is, as the name indicate, it's basically used for updating the value of a particular node. So as part of this implementation, what exactly we will do is, we will try to take the index and we will also try to take the new value for the node. So as part of the set functionality, what we will do is, we will try to reach the node that is available at the index given by the user, and whatever the value that we had in that node, right? And we make sure that we are updating that value with the new value. So that is the set functionality on a singly linked list, which is basically used for updating the value that is available at an index that is given by the user. Okay, since we are taking the index from the user, right, we know what all are the possible indexes for the singly linked list nodes, and it will start from 0 and it will end at length of the linked list minus 1. That means the indexes of the singly linked list that you see on the screen will be something like this. So as part of the set implementation, let's say the index that user gives is, let's say, 3. I want to update the node that is available at index 3 to a new value, let's say some text ABC. What we have to do is, we have to reach the node that is available at index 3 and we have to update the value that it currently has is test, right? And we have to update the value to ABC. So that is the main purpose of the set functionality. So what all are the different cases that could come? So obviously, just how we implemented in the case of get functionality, right? Whenever we are taking the index from the user, basically there could be two scenarios. One is the index that user is giving is valid index, or it could be an invalid index. And based on the value, new value, we don't have any restrictions, right? Singly linked list should store any value as part of the node's value. So there is no validation on the value that user is passing. The only validation that we have is in terms of the index that user is passing. So the different cases would be, first would be to check if the invalid index, and the second condition would be to check if the valid index. Okay, so we have to handle these two scenarios, right? But the thing is, by handling all those scenarios, we have already implemented a functionality called get functionality, right? And it will basically take the index, and based on if the index is valid or not, if it is a valid index, we will return the node that is available at that particular index. If the index is invalid, we will simply return null or none based on the programming language that we are using for implementing. So we are returning the entire node object. That means that node object that we are going to get as part of the get functionality will return the entire node, right? That means it will have the reference to the next node, and it will have the value as well. So if we can simply reuse the get functionality, we can simply update the node dot value with the new value that user is passing. We can simply update the value of a particular node. So we don't have to write the logic that basically handles invalid index and the valid index, the iteration logic that we have to write, right, to go to that particular node. The similar logic that we have written in the case of get functionality, we don't have to write all those things, and we can also basically reuse one of the functionalities. That is the main purpose of implementing any function, right? So we can simply reuse the get functionality here. So how will we reuse? We will simply call the get function with the index that user is passing. If the get function returns null or none, that means that it is a invalid index, because in the case of get implementation, if you remember, we will only return null or none if the index is invalid. Otherwise we would obviously return the node. This basically indicates that it is an invalid index. That's why we will simply return false, indicating that we haven't updated the node. Okay, otherwise if it is not null or not none, we have actually written the node, right? On that node, it is a singly linked list node of type node that we have defined. As a result, we can simply use that node dot value equal to new value. In this, by doing simple operation, we will be able to update the value we have in the node that is given at the index that is also given by the user. Okay, so that is how we reuse the get functionality for implementing the set functionality on a singly linked list. Okay, I hope things are clear to you. So far we have seen how can we implement the set functionality on a singly linked list, right? And the way I explained the logic is almost similar to how we write the pseudocode only. But anyway, go ahead and let's try to write the clear pseudocode for this. Okay, so as part of the set implementation, what exactly we will do is we will write a function called set, and here we will be taking two arguments from the user. One is index and the other will be new value that we want to use for updating the node's value. So obviously as part of the set implementation, immediately as soon as index is involved, right, we can simply call the get functionality that we have already implemented, and we will simply store it in one variable called node or something, right? And this get functionality is already implemented for valid indexes as well as invalid indexes. So in the case of valid index, it will simply return the entire node object, and in the case of invalid index, it will simply return null or none. If we are using Python, it will simply return null, none. So whatever the node return value that we are getting from the get functionality, right? If this node is null or if it is matching with none, that means that it is an invalid index. Here we can simply return false, indicating that we haven't updated the node because the index is invalid. So obviously we will not have the node at that index given by the user. If it is not equal to null, right, that means else block, what we will do, we will get the entire node object. So on that node we have dot value, right? We can simply read value of that particular node and we can simply assign new value to that. So how will we do that? So we have the node inside the node variable, and we can simply do node dot value equal to new value that user has passed. In the end, we can simply return true, indicating that the updation is successful. So that is how we write the pseudocode for the set functionality on a singly linked list. One thing that you have to understand here is, here our logic is completely based on the get functionality, right? So after that we are simply checking if it is a valid or invalid index based on the return type of the value, and we are simply returning true or false, and we are simply assigning new value to the value variable we are maintaining inside a node if it is a valid index that is given by the user. So obviously as a result, the overall time complexity and space complexity will be exactly similar to what we have inside the get functionality, because the overall time complexity of set implementation will become the time complexity of get functionality plus whatever the additional logic that we are writing. As part of the additional logic, if you see here, right, all the logics that we are doing are simply checks and assignment operations, and obviously they will take only constant amount of time. As a result, the overall time complexity will be similar to get functionality, and the overall space complexity will also remain similar to the space complexity that we have in the case of get functionality. Okay, so that is what we have in terms of writing the pseudocode for set functionality on a singly linked list. Now let's quickly write the implementation of the set operation, which basically takes the position of the node, and it will also take the new value for the node available at that specific position. It basically updates the node at that specific position with the value that user has passed. So here I just want to return Boolean type, whether we are able to update the node at that specific position or not, indicating whether it is successful or not. So the return type of the function will be Boolean. And let me just name the function as set. Here the first argument that we will be taking is index. We need to go to the node at this specific index, and we need to update this specific node value with the new value that user is going to pass. So the type of the value will be t according to the definition that we have passed when we initialize the singly linked list object. And let's just name this variable as new value. Okay, now first step is to go to this node available at this specific index, right? If you remember our previous discussions, we have already implemented one function called get, right? What this get function does, it basically takes the index and it will return the node that is available at that particular index if it is a valid index that user is passing. Otherwise, if the user passes an invalid index, it will simply return null. So based on this, we can simply reuse the get functionality first to get the node that is available at this specific index. After that, once we get the node, on the node we have the value variable, right? We can simply update that value variable with new value that user has passed. So here, as part of the first step of the set operation, we will simply get the node at that specific position. So let me just read the let me just get the node by calling the get function and by just passing the index that user has passed. Okay, remember that anyway, since we are taking the index from the user, if at all if user passes an invalid index, automatically it will return null, right? So based on the return value, we will be able to say if it is a valid index or not. So we can simply say if the node that I have got from the get function call, if it is equal to null, that means that user has passed an invalid index. So I can simply return false, indicating that we have not updated the node at this specific index because it is a invalid index. If at all the node that is given by the get function is not null, that means user has passed a valid node, valid index. Now we have got a valid node that is available at this specific index. Now on this node, we will have the value and we will have the reference of the next node. So that value, whatever we have, right, we need to update it with new value that user has passed. So we will simply do node dot value equal to new value that user has passed. That's it. In the end, we will simply return true because we have updated the node's value with new value, whatever that user has passed. Okay, now here we don't worry about the lengths, modifying the head nodes, tail nodes or anything like that, because we are simply updating the value that is there inside the node that is available at this specific index. Okay, so that is the simple and efficient implementation of the get operation. Remember that since we have handled both valid index and non-valid indexes in the case of get operation, here we are relying on the return value given by the get function call. So if the get function call returns a null value, it is an invalid index. That's the reason why we are simply returning false. Okay, so that is the set operation implementation. Now let's just try to call this and validate. So here let me just comment out the get function call. Rather, let's just try to set the value. Right now we have 3 values on the singly linked list. So valid indexes are from 0 to 2, right? So let me just pass the index 1 and I want to update the index node at index 1 with the value 100. So right now the node at index 1 is 10, right? So it should be updated to 100. So to check that, what we can do, we can simply uncomment this traverse operation. As a result, we should see basically index 1 getting updated with 100. So let's just run the code now. See, before setting the value, the values we had on the singly linked list are 0, 10, minus 10. After setting the index node at index 1th position with 100, see 10 got updated to 100. That is what you could see on the screen here.